Good evening, students and parents. Thank you for joining me today. My name is Chris, and I will be going through the OC class placement test mathematical reasoning paper that was released a few days ago on the government website. It will give you a good idea of how the OC mathematical reasoning section will look like when the students do this exam in July. So hopefully you guys enjoy the explanations, and we will go through every single question that's in this paper. So to start off, question number one, the triangle represents a number, and it says 67 minus triangle is equal to 32 plus 17, sorry. So to approach this question, the best way to start off would be to find out what this is equal to. So 32 plus 17 would be 49. So essentially it's 67 minus the triangle is equal to 49. So to find the triangle, you can also just say that the triangle is equal to 67 minus 49, which is equal to 17 So to do this, we borrow 1, so it's 5. 17 minus 9 is 8. 5 minus 4 is 1. So that means the triangle is equal to 18. So for question 1, the answer should be B. Moving on, for the next question, question 2, what number is 600 less than 74,251? So 600 is equivalent to just 600. So the question is essentially asking, what is 74,251 minus 600? So for this one, it's just a simple subtraction. So 1 minus 0 is 1. 5 minus 0 is 5. For the next one, we'll have to borrow. So 12 minus 6 is 6. 3 minus, if there's a gap down here where there's no numbers, that's essentially zeros. So 3 minus 0 is 3, and 7 minus 0 is 7. So the answer for that is 73,651. So the correct answer should be C. Okay, moving on. In terms of question 3, for question 3, Liu Wei got on a train at 20 to midnight. So to do this question, to start off, let's first write down what 20 to midnight is. So that would be 11. So 20 to midnight just means 20 minutes to midnight. So 11:40 p.m. He got off the train at 2:45 p.m. the next day. So 2:45 p.m. the next day. How long was he on the train? So I think the easy way to do this would just be to count from 11 p.m. to 11:40 p.m. to 2:40 p.m. the next day. So if we just count that, that should be, from 11:40, so 12:40, 1:40 in the a.m., 2:40 a.m., 3:40, 4:40, 5:40, 6:40, 7:40, 8:40, 9:40, 10:40, 11:40 a.m., 12:40 p.m., 1:40 p.m., and 2:40 p.m. So that would be from 11:40 p.m. to 2:40 p.m. the next day. If you're counting on your fingers, that would give you plus 15 hours. And then to get from 2:40 p.m. to 2:45 p.m., that's a simple matter of just adding 5 minutes. So that answer should be 15 hours and 5 minutes. So that would be E. Okay, moving on. Question 4, the shape below is made up of 8 small squares, all the same size. How many more squares need to be shaded so that 3/4 of the shape is shaded? So 3/4 of 8. So we're trying to find what 3/4 of 8 is. If you know how to do fractions, that's just 3/4. Of means multiply of 8. So if you want to do that, you just do 8 over 1. So if you're multiplying, you can cross simplify. So what can you divide both 4 and 8 by? You can divide both by 4. So this one you can simplify down to 1, and this one you can simplify down to 2. So if you multiply them together, across the top 3 times 2 is 6, and then on the bottom 1 times 1 is 1, so 6 over 1 is just equal to 6. You can also probably just look at it and just see and ask yourself what is 3/4 of 8. And for a lot of students, just by looking at that, you can kind of observe that it's just 6. So we want to essentially color in 6. So essentially everything on the left of that line. So how many more small squares? So the key word is more. So how many more small squares do we need to shade? It would be 1, 2, 3, 4, 5. So the correct answer for this one is D. Moving on, let's do question 5. If each of these numbers is rounded to the nearest 10, which number changes the most? So for this one, let's just first round them all to the nearest 10. So 45, that will round up to 50. 54 will round down to 50. 77 will round up to 80. 80 will just stay at 80. And then 99 will round up to 100. And then let's do it in blue. But in blue, we'll see how much it changed. So this one changed by 5. This one changed by 4. This one changed by 3. This one changed by 0. And the last one changed by 1. So the one that changed the most would be option A. So for question 5, the correct answer would be A. Okay, moving on. For question 6, Claire, let me zoom out a little bit there. So Claire is standing at X in the center of the grid. She follows these instructions one after the other. So for these ones, you just want to draw a very clear diagram. So starting at the cross, she walks 30 meters north. So this one, they're actually quite nice and made it easy for you. So each little side of the square is 10 meters. Sometimes the question, just a bit of advice, sometimes they'll make it tricky, like each of these might be 5. So if you want to move 30 meters north, you will have to move 6 grid boxes upwards, rather than when, instinctively, a lot of people, when you see 30 meters north, you instinctively just move 3 boxes north or 3 side lengths north. So that's something just to be careful of. But for this one, they've been quite nice to us. So each side length is 10. So if you want to move 30 meters north, you would move up 3. So 1, 2, 3. So now you're here. And then you want to go 20 meters east. So 1, 2. And then just in case students don't know, if you have your north, east, south, west, so you can do your normal never eat soggy wheat bix. So I would recommend drawing that down if you haven't memorized your directions. So in clockwise directions, in NESW, so never eat soggy wheat bix. So we were up to step 2, so walk 20 meters east. So we just did that. And then let's go 70 meters south. So we need to move 7 side lengths down. So 1, 2, 3, 4, 5, 6, 7. So we're down here. And then we walk 20 meters west. So 1, 2. So we're back here. So the question asks, how far is Claire from her starting position? So let's go up. So 1, 2, 3, 4. So it's 4 side lengths. And if each of them is 10, so it's just 4 times 10. So that is 40 meters. So the correct answer for question, I believe this is question 6, should be D. Okay, let's move on. So for question 7, in the 5 circles below, Hero is going to write the numbers 1, 2, 3, 4, 5 once each. The 3 numbers in each line must add up to 8. So that's a bit of key information. They have to add up to 8. What number must Hero write in the middle circle? So for these type of questions, I always recommend doing a bit of educated guessing and checking. So let's kind of, pick, let's say if I just randomly guess, maybe I might put 3 in there, okay? So say if I did randomly pick 3 and choose to put 3 in there, and that means I've used up the number 3, so I have to put 1, 2, 4, and 5 in there, okay? So to get to 8, if I have already put 3, that means I need the other numbers to, the opposite numbers to add up to 5. So I could put 1 and I could put 4, right? So I could put, 1 and 4, which would work. But if I put the remaining numbers 2 and 5, that doesn't work. That adds up to 7. So this is where the educated part of the educated guessing and checking comes in. So when I look at that, I know that the number that I put in the middle is way too big, because 1 and 4 worked, but the remaining two numbers added up, it gave me the sum of 10 when I added up these three. That means the middle number needs to be a bit smaller. So maybe let's try the number 1. Okay, so if I just erase everything and try the number 1. So let's take out the number 1. Let's put number 1 in the middle. And I ask myself, okay, if I want each row or each line to add up to 8, and I put 1 in the middle, that means the 2 circles at the end have to add up to 7. So if I put down 2, I could also choose 5 to add up to 7, right? So that works. And then the other 2, which is 3 and 4, they also add up to 7. So that would be 3 and 4. So that combination does indeed work. So the correct answer for 7 should be A. Okay, let's move on to the next question. So for question 8, it says, Ollie makes a necklace by putting beads on a string. He makes the necklace by repeating this step. So he starts off with 2 red beads and then 3 blue beads. So what it would look like, say if I had a string like this, so what that would mean is there would be 2 red beads and 3 blue beads. I think most kids would be able to imagine this, but I'll just draw it out just for explanation's sake. And then say you keep repeating it, you have another 2. And then you would have 3 more blue. So what you can see here is, in terms of these ones, they come in a combination of 5 blocks like that. So what that means is, if there were 12 blue beads, that means there are, so if there's 12 blue beads, that means there are 4 lots of the blue beads, which means in this sequence, you would also get 4 lots of the red beads, which means how many red beads would there be altogether? It would be 2 beads and there'll be 4 lots of it. So 2 times 4, which is equal to 8. So the correct answer for question 8 would actually be B, option B, which would be 8. Okay, moving on. For question 9, it says 2 containers of water are shown below. Water is poured from X into Y until Y contains 8 milliliters altogether. How much water is left in container X? So if we pour Y up until 80 milliliters, the gap here is 20 milliliters. So that means this one will actually go down by 20 milliliters as well. So which one, how much water is in container X? So if we look at this line here, that's where the water is. It is halfway between 30 and 40, which means that it is at 35. So if we take out 20, we just minus 20, which will give us 15. So the correct answer for question 9 would be option C, which is 15. Okay, so for question 10, it says a wire of length 80 centimeters is made into a rectangle. So it looks something like this. Okay. And it says the 2 side lengths of the, or 2 sides of the rectangle are 10 centimeters long. And all of the wire is used. What is the length of one of the longer sides of the rectangle? So the 2 shorter sides add up together to be 20 centimeters. So that means for the 2 shorter sides, 20 centimeters of the 80 centimeters is used. So 80 minus 20 is 60 centimeters. So for the remaining 60 centimeters, that will be shared between these 2 sides. And because they're opposite sides of a rectangle, they are equal. So if they're shared equally, that would just mean 60 divided by 2 is will be your answer. So that would give you 30 centimeters. So this would be 30 centimeters, and so will this one. So that means the correct answer for 10, what is the length of one of the longer sides of the rectangle? The correct answer would be C. So 10 would be C. Okay, moving on. So if we look at question 11, here are 3 cards showing the digits made up of horizontal and vertical lines. if you choose two different cards, what is the largest possible number of right angles you can count in your digits? So the best way is just to start off would just be identify how many right angles are in each number. So this one we have 1. Actually, I might zoom into this one to make it a bit clearer. I'll zoom in there. So for this one, there is 1, 2, 3, 4, 5. So here there are 5 right angles. For the next one, there is 1, 2, 3, 4 right angles. And just in case you were wondering, these do not count as right angles. So a right angle is 90 degrees. The blue ones are 270 degrees. So that is not a right angle. Just to clarify, as sometimes students do get that mixed up. And for the final number, there is 1, 2, 3, 4, 5, 6 right angles. So which ones would give us the most number of right angles if we pick 2 of them? Obviously, it would be the first number here and the second number here. So 5 right angles plus 6 right angles, that should give us 11 right angles. So let's zoom out and see which answer that is. That would be option E. So question 11, the correct answer should be E. Okay, moving on to the next one. So for question 12, it says wolf dog food is sold in 2 different sizes. A box containing 500 grams, a box containing 500 grams costs $1, and a box containing 2.5 kilograms costs $4.50. The question asks, Joe needs to buy exactly 4 kilograms of dog food. What is the lowest price he can pay? So in terms of this, there is a number of different ways you can do it. So if you want to buy exactly 4 kilograms, there's 2 ways of doing it. Either you can just buy 8 lots of 500 grams. So you can fit 8 lots of 500 grams into 4 kilograms, which will just simply be $1 times 8, because you're having 8 lots of that. So that will give you $8. Or the other way to do it is actually to buy 1 of these 2.5 kilograms and to fill up the remaining amount to reach 4 kilograms by actually buying 3 of these. Okay, so we can buy 1 of these and 3 of the 500 grams, which would be, if I buy 3 500 grams, that would give me $1 multiplied by 3, which is $3. And I have to just do $3 plus the cost of 1 of these 2.5 kilogram boxes, which is $4.50, which will equal to $7.50. So the least I can spend is actually $7.50. So we'll see if there is a correct answer that says $7.50. And indeed there is. The correct answer for that question would actually be E. So question 12 is E. Okay, moving on. Question 13, it says in this diagram, 8 plus 2 equals to 10. Here's a new diagram that works in the same way. So for this, these diagrams, essentially what's going on is simply that the bottom 2 numbers just add up to give you the number in the circle that those 2 circles are connected to, okay? So it says for question 13, what is the value of Q multiplied by R? So Q is this one, and R is this one. So to get P plus 41 is equal to 110. So P is equal to 110 minus 41. So if I do that, that would be, I have to borrow 1 there, so that becomes 0. So that's 10 minus 1 is 9. And then I have to borrow another 1, so 10 minus 4 is 6. So P is equal to 69. So let's write that in a different color there. Let's pick blue. So P is equal to 69, which means R, so what plus 61 gives us 69? That would be 8. And then what plus, to find out Q, what plus 32 gives us 41? That would be 9. So what's Q multiplied by R? That would be equal to 9 multiplied by 8, which is equal to 72. So the correct answer for 13 will be B. Okay, let's move on to the next question, question 14. So for question 14, it says Rachel makes this object by gluing together 9 identical cubes. She can pick up the object and look at it from any direction. How many faces of the cubes can she not see? So for these type of questions, it's always best to go through it very methodically. So what I mean by that is, let's have a look at the shape above. So let me zoom in a little bit. So for this shape, there's actually 3 different types of cubes. So you have the ones that are labeled as number 1. So these are the ones that sit on the corner, okay? And for these ones, what you can see is there are 2 sides that you cannot see for those ones. So what I mean by that is I'll draw it here, but there's the one that's at the bottom and the one that's on the left there that you cannot see. So for the number 1 cubes that I've labeled there are actually 2 sides that you cannot see. Okay, so I'll write it here on the right hand side. So for the number 1 type of, or the type 1 cubes, there are 2 sides that you cannot see. Okay, now for the type 2, I can call them these ones which are on the edge. Okay, so for these ones, there are a few that you cannot see. So I'll rub that out and show you. So for these ones, if I draw in the sides, there's the one that's there. Okay, so for these ones, there are actually 3 sides that you can't see. The one that's there at the top, the one that's on the left, and the one that's at the bottom. So for the number 2 types of cube, the type 2 cubes, there are 3 sides that you can't see. Okay, and the final one is the type, I'll just call it type 3. That's the one that's sitting right in the middle, and there's only one of those cubes. So if I draw in the sides, I think the diagram they gave us wasn't fantastic because it looks like there's a few missing lines in there. But if I draw this one here, right? So that's that cube. For these ones, there are 4 sides that you cannot see, okay? And let me show you that. So for type 3, there are 4 sides that you cannot see. So it would be the one on the, just accidentally rub that out. So for this one, it's the one on the right, the one on the top, the one on the left, and the one on the bottom. The only 2 sides you can see is the one that is at the front here, and then there will be another one on the back side of the shape. Okay, so I think I rubbed out a few things. So just reversing that and having a look on the right hand side. These are the different types of cubes that I have. I just called them type 1, type 2, type 3. And the number of sides is the number of sides that you cannot see. So let's see how many of the different types that we have. So for type 1, we have 1, 2, 3, 4. For type 2, we have 1, 2, 3, 3, 4. And then for type 3, we just have 1 in the middle there. So there are 4 lots of, so in terms of type 1, there are 4 of them. So there's 4 lots of 2 sides that cannot be seen. So 2 times 4 is 8. For type 2, there are 4 lots of 3 sides that you can't see. So 3 times 4 is 12. And then for type 3 type of cubes, there's only 1 type of that cube. So 4 sides, so 4 lots of 1, that is just 4 times 1, which is 4. So if we add that together, that will give us the total number of sides that you cannot see. So 8 plus 12 is 20, plus 4 is 24. So the correct answer for that question would be C. So for question 14, the correct answer is C. Okay, so for question 15, the best way to go about this would be to work backwards. So it says, in a sequence, each number is 4 less than double the previous number. So it is 4 less than double the previous number. So what it's saying is, you have, say, a number here, question mark. So what you do is you double it, then minus 4, and then that will give you the next number. So if Jasper finds a number directly before 36, so it's saying 36 is the next number, and Jasper found the number that was before it, okay? So this type of question, we want to work backwards. So what we had there was -4, so we want a +4, so that would take it to 40, and then it was doubled, so we want to do the, working backwards, we want to do the opposite, which will be divide by 2, which will take us to 20. So the previous number would be 20, okay? And then it says that answer has 2 digits, and he adds these 2 digits to get a new number. What is the new number? So the 2 digits are 2 and 0. So if I add 2 and 0, that would just simply give me 2. So correct answer for 15 would be A. The answer is 2. Okay, moving on to the next one. So Joe has 3 cards. Each card has a different number on it. So 4, 2, and 9. She uses all 3 cards to make different 3-digit numbers. What is the difference between the largest? What's the difference between the largest 3-digit number Joe can make and the smallest 3-digit number Joe can make? So a bit of a tips and tricks for this type of question. So when you have digits and you're trying to make the largest number, you always want to put the digits in descending order. Okay, and then when you you're trying to find the smallest number, you always put it in ascending order. So descending just means from the larger numbers to the smaller numbers. And then for ascending order, it just means you're going from the smallest number to the largest number. So that's how you find the largest and smallest numbers that you can make from a group of digits. So if you're trying to make the largest 3-digit number and I put them in descending order, it will be 942. And if I'm making the smallest 3-digit number, I'll put them in ascending order, so 249. So what is the difference? So I just subtract them. So if I subtract that, the 4 becomes a 3 because I need to borrow 1. So 12 minus 9 is equal to 3. 3 minus 4, I can't do that, so I need to borrow a 1. So 13 minus 4 is 9, and then 8 minus 2 is 6. So 693 would be the correct answer for question 16. So 16 is D. Okay, and let's keep moving. So for the next question, question 17, it says, Bilal opens a new shop, and the shop is open Monday to Friday. Below are 2 column graphs showing the sales of umbrellas in Bilal's shop in the 2 weeks after opening. So there's week 1 here and week 2 here. Bilal wants to sell more umbrellas in week 2 than week 1. What is the smallest number of umbrellas that he needs to sell on Friday? So you can see that this one is missing a Friday column. What's the smallest number of umbrellas he needs to sell on Friday of week 2 to achieve this? So what we need to do is just count the number of umbrellas sold in week 1. So this is 6, this is 5, this is 7, this is 3, and this is 4. So if we add all these numbers together, 6 plus 5 plus 7 plus 3 plus 4, that will give you 25. And so let's have a look and count what we've got on Monday, Tuesday, Wednesday, Thursday for week 2. We've got 7, 5, 5, 6. So if we add those ones together, that will give us 23. Now, if we want to sell more in week 2 compared to week 1, we obviously need to sell 26. So how many more do we need to sell on Friday to reach 26? The correct answer for that one would be 3, option B. So the correct answer for question 17 would be B. Okay, moving on. Question 18. Here are 3 squares, X, Y, and Z. Which of the squares has or have 2 8s shaded? So 2 8s just means 2 out of 8 parts. We can simplify a fraction by just dividing the top and bottom number by the same number. So that could also be written as 1 out of 4 parts. So let's have a look at each of X, Y, and Z. So for the figure X, the diagram has 2 out of 4 sections shaded. So that is not one of the correct figures or squares. Option Y, if we actually split it up, we can see there are 8 sections and 2 of them, this one and this one, are shaded. So that is indeed 2 out of 8 shaded. And then for the final one, Z, that one has 4 sections and 1 out of the 4 is shaded. So 1 out of 4, which is the same thing as 2/8. So 1 is the same thing as 2/8. So that means Z, figure Z or square Z is also a correct answer. So for question, what number is this? So for question 18, both Y and Z are squares that have 2/8 shaded. So the correct answer for this one would be E. So for question 18, the correct answer is E. Okay, moving on to the next question, question 19. Here are the first 4 terms of a number sequence. What is the difference between the 4th term and the 6th term in this sequence? So if you look at this sequence, it's not too hard to recognize what it's doing. It's just simply doubling. So 3, 6, 12, 24, 48, 96, yep, so this one would be the first number, second number, third number, 4th number. So that's the one we care about. 5th number, and 6th number. We also care about the 6th number. So what is the difference? So difference is just subtraction. So 96 minus 24, which if we minus, that would 6 minus 4 is 2. 9 minus 2 is 7. So the correct answer for that is 72. The correct answer for question 19 would be D. Okay, now let's move on to the next one. Okay, so for question 20, Hassan goes to the shops with his pocket money and he spends 1/3 of it in the first shop and 1/6 of it in each of the shops that he visits. He has 1/6 of his pocket money left at the end. How many shops does Hassan visit altogether? So the best way to actually do this would just be to get one whole and just minus 1/3 and just keep minusing 1/6 until you're left with 1/6 at the end. So you can do it that way. Another way that you can do is just draw a diagram. So let's draw a diagram with 6 parts in it, okay? So 1/3, and if I want to make it out of 6 parts, what I do is just times the bottom and the top both by 2. So 1/3 is equal to 2/6. So if he spends 1/3 in the first shop, that means he spends 2 pieces out of the 6 pieces in total. So that's the first shop that he visits. And then he spends 1/6 in each of the other shops that he visits until he has 1/6 left. So the one that he has left at the end, let's just put it in a star there. So let's say he's not spending that one. So and he spends 1 piece out of the 6 pieces or sections in each of the other shops. So that's one shop, that's another shop, and that's another shop. And then that last one here is the remaining pocket money that he has left over at the end. So how many shops did he visit altogether? So there are 4 shops that he has visited. So for question 20, the correct answer is B, 4. Okay, moving on. Question 21, it says Ellie is going to shade 3 more squares in the diagram above. Okay, so actually for this question, I think there is a slight error. I believe this one should actually be shaded as well. So I'll just shade that in there. So Ellie's going to shade 3 more squares in the diagram above. She wants the dashed line to be a line of symmetry. When she has finished shading, the patterns of the squares on the left and the right will be reflections of each other. So what are the grid references of the 3 squares Ellie needs to shade? So if I'm shading, what I need to do is I want to look at this line. So if it's a reflection, this one reflects this one reflects this one, this one reflects this one, this one reflects this one, this one reflects this one. So obviously I need to shade this one in. This one would reflect that one, so I need to shade that one in. This one reflects that one. That's both are already shaded, so no need to shade anything. And this one will reflect that one, so I need to shade this one in. So altogether, in the diagram above, or the diagram here, the 3 that need to shade are the ones that are in red. That one blue one, I think they should have shaded, but it was an error in the question booklet. So what are the coordinates for each of them? So how you read coordinates is you read the horizontal axis first, which is just the one that's horizontal. So you can remember like the horizon at a beach. It's, it's a flat line like that. And then here you have the vertical axis. So you always read the horizontal one first, and then you read the vertical one. So V2 is this one. This one is U4. U4. Oh, sorry. 4. And this one is Q5. So which one matches those ones? D. So Q5, which is this one, U4, which is that one, and V2, which is that one. So the correct answer for question 21, is D. Okay. Moving on to the next one, question 22. It says, the diagram shows the locations of trees in a park. On this diagram, north is to the right as shown. So once again, if they've given us something weird, like north is not pointing upwards, it's pointing to the right, let's draw it in the other directions as well. So never is clockwise, so never eat, so east, soggy, so S, Weet-Bix, W. So that's the new compass in the edited orientation. So a bird watcher stands at T5. So T5, so T is here, 5 is here. So T5, so T5 is this X that I've drawn in the middle. And there's a bird sitting in a tree southwest. So looking at the diagram at the, or the compass directions at the top, which one is southwest? The southwest would be in that direction. So if I draw a line, it's in this direction. The tree is more than 25 meters away. So what is the grid reference for the tree where the bird is sitting? So more than 25 meters away. So if I I know the, here, if I look in the top right, the 10 meters is just one side length. Obviously it doesn't tell us what the diagonal ones are, but you can just look at it and realize. So for example, if I do it in yellow, this is how long 25 meters would be. Obviously, if I kind of just rotate that around, the 25 one might end up be around here. So definitely this tree here, the closer one, is not more than 25 meters away. So it must be this one that they're talking about. So if I look at the coordinates of that, once again, from the previous question, I remember you have to look at the horizontal one first. So that's Q. And then the one on the vertical axis is 8. So the correct answer for question 22 is actually Q8. So option B is correct for question 22. Option B, Q8. Okay, let's move on and keep going. So for question 23, it says, to feed 8 penguins, a zoo needs a total of 24 kilograms of fish per week. And to feed 4 sea lions, it needs 24 kilograms of fish per week. How much fish would the zoo need to feed 4 penguins and 8 sea lions? So 8 penguins required 24 kilograms. So 4 penguins is half as many penguins. So you only need half that amount of fish. So half of 24 would be 12 kilograms. And 8 sea lions is double of 4 sea lions. So you'll eat twice as many kilograms of fish. So twice of 24 kilograms is 48 kilograms. So I need, how many fish would the zoo need in total for 1 week? So it would just be 12 kilograms plus 48, which would be 2 plus 8 is 10. So carry the 1. 1 plus 1 plus 4 is 6. So you will need 60 kilograms of fish. So for question 23, the correct answer is D. Okay, moving on. So for question 24, it says a square piece of centimeter squared paper is folded as shown. The section shaded black are then cut out and thrown away. The paper is unfolded completely. What is the area of paper that is left? So this type of question, you don't want to be, trying to unfold in your hand and imagining it. This is a type of question where you have to think very intelligently and think of a way to approach it, which will make your job easy. Now, if I'm folding the paper in the diagram above, like up here, essentially, when I get to this final one, there are 4 layers on top of each other. So if you don't believe me, just get a piece of paper and fold it in the same way that is demonstrated in the diagram. And when you look at the final piece of paper that's folded, you'll see that there are 4 layers, okay? So 4 layers. That means if I look at the diagram and see what black parts are cut out, simply I just multiply that by 4, and that will give me the overall of paper, area of paper that is missing. Okay, so it says that it's a centimeter squared paper, which essentially means that each side length here is 1 centimeter. Okay, so let's count out and see if each, each square is 1 centimeter, has a side length of 1 centimeter. That means the area is just the side lengths times together. So each square is 1 centimeter squared. Okay, so let's have a look at that. So now that we've talked about that, this little triangle is actually 2 halves of the square. So 2 halves added together will give me 1 whole square. So that is 1 centimeter square. Let me actually do it in a different color so it's clear. So this will be this one will be 1 over here. This one here actually will fit in this little gap there. So that will actually be 1 centimeter square as well. If I look here, that's 1, that's 2, that's 3. So that would be 3. And then these two over here and over here will add up to give me 1 whole centimeter square. So adding them together, I have 1, 2, 3 plus another 3 would be 6. So that's 6 centimeter squared that is missing. And then if there's 4 layers, that means I've cut out 4 lots of that. So 6 centimeters squared multiplied by 4 is equal to 24 centimeter squared that is missing, which means that if I unfold it, what is left would be the total amount, which was, let's have a look at how long the side length, what the total area actually was of the original piece of paper. So 1, 2, 3, 4, 5, 6, 7, 8. So this was 8 centimeters long. 1, 2, 3, 4, 5, 6, 7, 8. This is 8 centimeters long. So originally it was actually 64 centimeters squared, because to find area, you just do the side lengths multiplied by each other for a square or rectangle. And you minus the missing amount, which is 24 centimeters squared. So that will give you 4 minus 4 is 0, 6 minus 2 is 4. So that will give you 40 centimeters squared remaining at the end. So the correct answer for that would be, let's do it in red because I've been doing it red so far, I believe, will give you D. So the correct answer for 24 is D. Okay, moving on. Okay, so for question 25, it says a pen costs $1.40 and a pencil costs 80 cents. Susie buys a pen and pencil and pays with a $10 note. The shop assistant has no $1 or $2 and no notes, coins and no notes. Susie's change contains exactly 9 50-cent coins. What is the greatest number of 20-cent coins that Susie could have in her change? So let's just follow the question and just do what it's telling us. So Susie buys a pen and pencil. So a pen costs $1.40 and a pencil costs 80 cents. So 80 cents is the same as $0.80. So let's add that together. So $1.40 plus 0.80. So add that together. That will give me 0. 4 plus 8 is 12. Carry the 1. 1 plus 1 is 2. And then I bring down the decimal. So $2.20. And she pays $10. So how much change should she get? So it should be $10 minus $2.20. So a whole number actually has a decimal at the end, and you can just add zeros, as many zeros as you want. So I'll just add 2 because for $2.20, there are 2 digits. Well, you can take away the 0, but I'm just going to keep it as basic as I can. So $10 minus $2.20, I'm going to minus that, and that will give us how much change Susie should get. The 0 minus 0 is just 0. 0 minus 2, I can't do it, so I need to borrow the 1 from here, so that disappears, and this 0 becomes a 9, and then I have a 10 here. So 10 minus 2 is 8, and then 9 minus 2 is 7, and then I bring down the decimal. So she should get $7.80 change. Now, if she has already 9 50-cent coins, so that is 9 times 0.5. So let's do that. So 9 times 0.5 is, so 5 times 9 is 45, and then 0 times 9 is 0, so you can put a 0 there if you want. And then how many digits are after the decimal? So it's just 1. So I put down the 1, the decimal with 1 number, the 5 behind it. So if she has 9 50-cent coins, that will be equal to $4.50. So that means she has already got $4.50. So $4.50 there. And that means there are, let's subtract it. How many dollars remaining? 0 minus 0 is 0. 8 minus 5 is 3. To put the decimal there, 7 minus 4 is 3. So there's $3.30 left to account for. And so what is the greatest number of 20-cent coins? So obviously we want to put as many 20-cent coins in there as possible. Now, most students would already know that in $1, there is 5 lots of 20-cent coins, right? So in $3, there is 3 lots of $1. So that means I'll get 3 lots of 5 20-cent coins. So I'll have 15 coins in total. And the last 30 cents, I can fit 1 more 20-cent coin in there. So I just plus 1 more coin. and that will give me 16 coins, or 16, sorry, 20-cent coins. So the correct answer for question 25 would be B, 25B. Okay, moving on, moving to the next question, question 26, 11th of August, 1999 was a Wednesday. Which day of the week was the 21st of September in 1999? So what you could do is, you could subtract the numbers, there's 31 days in August, and subtract 31 from 11 and just figure out how many days between there, and essentially just count it, or every lot of 7 days is a whole week, so you can do it that way as well. But I'll do it in a way which is very simple and very easy to track, and very hard to make a silly mistake with. So we've got the 11th of August, okay? So if I add 7 days, that will give me 18th, and that will still be Wednesday, okay? Because a week later, 7 days later, is still Wednesday. Let's add another 7 days, so that gives me the 25th. That's 7 days, so that's still Wednesday. And I need to add another 7. So it's a bit tricky, because then it takes me to the 32nd. Obviously, there aren't 32 days in August, so let's just count 7 days and see what day that will end up with. Just keep in mind, there are 31 days in August. So 26th, 27th, 28th, 29th, 30th, 31st, and the 1st. So if I add 7 days, that will take me to the 1st of September, and that's still another Wednesday. And let's just keep adding 7 days. 8th, 15th, 22nd. So if I go to the 22nd of September, that's a Wednesday. Now, it wants me to go to the 21st of September. So that is just simply 1 day before. So what day is 1 day before Wednesday? That would be Tuesday. So the correct answer for question 26 would be E. Okay, let's move on to question 27. It says, a group of children were asked how many pets they had at home. The graph shows the result, okay? Mary reads the graph and makes 3 claims, okay? Claim number 1 was more than 100 children have 1 or 2 pets. Number 2, exactly 3 times as many children had 2 pets as 0 pets. Number 3, there were 24 more children with 2 pets than children with 3 pets, okay? Using the information on the graph, which of Mary's claims is or are incorrect? Okay, so looking at that, let's go through each one at a time. So going through each one at a time, number 1, more than 100 children had 1 or 2 pets. So number 1, how many kids had 1 pet? If we draw the line and trace it across, that's 40. And how many kids had 2 pets? If I trace that along, that would give us 1 increment less than 50. So between 40 and 50, there are 5 increments or 5 gaps there. So that means each gap is equal to 2. So if it's 1 less than 50, so that's 50 minus 2, which is, this one is 48. So 40 plus 48 gives me 88. That means number 1 is actually incorrect. Okay, let's look at the next one. So the next one is exactly 3 times as many children has 2 pets as 0 pets. So exactly 3. So if we look at 0 pets and trace across, it's 1 increment more than 10. So that's 2 more than 10, which is 12. And for 2 pets, we did it already before, and we said it was 48. Is 12 multiplied by 3 48? No, that's incorrect. 12 multiplied by 3 is actually 36. So claim number 2 is incorrect. Now let's look at claim number 3. There are 24 more children with 2 pets than with 3 pets. So 2 pets, we already know that there are 48. 3 pets, let's draw the line across and trace it there. So that is 2 increments more than 20. So if each increment is 2, that means 2 increments would be 4 points. So 4 is equal to, 4 points, so 4 more than 20, which is 24. So that means there were 24 more children than 2 pets than with 3 pets. That's correct, because 48 is 24 more than 24. So claim number 3 is correct. So the correct answer for this question is C. Okay, so I believe that's question 27. Yep, question 27. The correct answer is C. Okay, let's move on to the next question. So for question 28, this is Amanda has a large cube made of 4 small gray cubes and 4 small white cubes. She can look at it from any direction. She can see 24 faces of the small cubes, which makes sense because each side has 4 faces. So if there's 6 sides in total, it'll be 4 times 6, which is 24. So Amanda breaks a large cube into 2 equal objects as shown below. She picks up the objects and looks at them for all directions. How many faces of the small cubes can Amanda see? So once again, these type of questions where involve a lot of thinking, we try to do it in a smart and intelligent way. So if I ask, if there were kids here listening to me and I asked them, how many faces does a cube have? There would be, kids would generally say 6. And then if there's 4 of these, how many would there be? 4 lots of 6. That would be 24, right? Okay, good. But there are some faces that I can't see in this structure. So let me draw that out for you, okay? So if I draw this here, you can see for these shapes, they are connected across 2 sides. So there's this side here that connects the shape that's at the front and the back. There's this one here that connects the one on the left and the front. And then there's also the one at the face at the bottom, which connects the one at the front and the one at the bottom. So how many sides do we lose? Well, at each of the 3, I guess, junctions or meeting points, we lose 2 faces. So that 2 times 3 would just be 6. So it will be 24 minus 6. So 24 minus 6 is just 18. So that means for each of these figures, or the 3D figures, I have 2 of them, I can see 18 faces. So how many faces of the small cubes can Amanda see? That would be 18 multiplied by 2, which is equal to 36. Okay, so if I look at the options below, I should look for 36, and that would give me option C. So the correct answer for question 28 would be option C. Okay, moving on. Question 29. Jack and Sarah had 12 strawberries. They ate all of them. Sarah ate twice as many strawberries as Jack. How many strawberries did Sarah eat? So I'll explain this with a simple diagram. So let's just say this box or this square is how many Jack ate. Sarah ate twice as many of them. So she ate 2 of them, okay? So this square just represents a number. So that means the strawberries here, Sarah ate 1 of them, and, Jack ate 1 of them, and Sarah ate 2 of them. So how many strawberries does each square represent? So if there's 3 of them, and they all add up to 12, each of them, just 12 divided by 3, would represent 4, okay? Oh, sorry, I accidentally wrote 2 here, but it actually should be S for Sarah. Now, how many strawberries did Sarah eat? So she ate 2 squares, each of them representing 4. So 2 lots of 4 would be 8. So the correct answer for question 29 would be D. Okay, moving on, question 30. Peter starts with a piece of paper in the shape of a triangle as shown. He makes just 1 fold in the paper without moving in any other way. Which of the shapes could not be the result? So for question 30, I think the best way would be me to tell you what the answer is. The correct answer will be A, and I'll show you how you can get B, C, D, and E by folding the paper. I'll just draw a red line. So for question B, I could fold it there and fold this one. Let me draw it again. So I could make a fold here and fold the top piece down, and that would give me the shape on the right. For option C, I could fold this one here and just fold the piece on the bit on the right over to the left, and I'll get my figure that I see on the right hand side. I can get this figure here. Okay. For option D, what I could do is I could fold this one from up there to down here, and that would give me the figure there. And then for E, what I could do is I could kind of fold it here and take the whole left side over to the right, the whole right side to the left side, so that it covers this little triangle there, and that should give me the shape on the right hand side. So I can do those folds for all of those shapes to get the figures on the right, but for option A, there is no fold that you can do to get the figure on the right. Okay, moving on. Just a few more questions left and we'll be done. So question 31, it says Ethan draws a rectangle 4 centimeters long and 3 centimeters wide. Here's has a paper rectangle which is 2 centimeters long and 1 centimeter wide. So this one is 2 centimeters long and 1 centimeter wide. And he wants to put in 4 positions, P, Q, R, and S, to make a new shape. Ethan wants the perimeter of the new shape to be 4 centimeters more than the perimeter of his starting rectangle. So whenever I add a rectangle on, you will add some sides and you'll also lose some sides. So what do I mean by that? Let's just have a look at rectangle P. Now, if I look at rectangle P and I put that on, I will add 1, 2, 3, 4 centimeters, but I will lose these 2 centimeters down here. So overall, that gives me an additional 2 centimeters there, okay? If I look at Q, I will have an additional 1, 2, 3, 4, 5 centimeters, but I will lose 1 centimeter. So that gives me an overall increase of 4 centimeters, okay? Now, if I look at R, I will have 1, 2, 3, 4, 5 centimeters added, and I'll lose 1 centimeter, which gives me an overall increase of 4 centimeters. And for S, I will have 1, 2, 3, 4 centimeters added, and I will lose 2 centimeters. So overall, I will have an increase of 2 centimeters. So which of the following rectangles added would give me we'll add 4 centimeters to the overall perimeter? That would be rectangle number Q and rectangle R. Okay, so which one is Q and R? There's an option D and E, which is kind of cut off at the bottom, but I can see that option C is correct for question 31. Okay, let's move on. Question 32, I'm playing a computer game and I have 1,000 points. In the game, I buy 5 buildings, each costing 106 points. I also buy 1 farm and I have 140 points left afterwards. How many points did the farm cost? So 5 buildings, each of them is 106 points. So just 106 multiplied by 5. That gives me 6 times 5 is 30. So put down the 0 and carry the 3. 5 times 0 is 0, plus 3 is 3. 1 times 5 is 5. So that is 530 points. So if I spend 530 points out of the 1,000, how many do I have left over? I borrow the 1, and that gives me 10 there, and these ones become 9. So, sorry, that's my mistake. Let me go back a few steps. It's careless error, late at night right now. So 0 minus 0 is 0. 0 minus 0 is 0, and then 0 I can't minus 3, so I need to borrow that 1, so that becomes a 10 and that becomes a 9. So 10 minus 3 is 7, and then 9 minus 5 is 4. So I have 470 left, and then I buy a farm, and that takes me down to 140 points. So how much did the farm cost, right? So that's just a simple 470 minus 140, and that will give me 0. 0 minus 0 is 0. 7 minus 4 is 3. 4 minus 1 is 3. So that means the farm cost me 330 points to buy, which is option A. So 32 is A. Okay, the question 33, moving on. Jess has a bag of 11 counters numbered 1 to 11. Without looking, she takes 1 counter out of the bag at random. Which of the following statements below is or are correct? Statement number 1, Jess is equally likely to take out an even number or an odd number. Okay, if we look at it, how many even numbers are there? 1, 2, 3, 4, 5. How many odd numbers are there? 1, 2, 3, 4, 5, 6. So there are actually more odd numbers. So Jess will actually have a better chance of picking out an odd number compared to an even number, just because there's more odd numbers, right? So option 1 is not correct, or statement 1 is not correct. Number 2, Jess is more likely to take out a number greater than 6 than a number less than 6. So let's erase that. So number 6 is this one. So for number 6, if I cross that out, how many numbers are less than 6? There are 5. And then how many numbers are more than 6? There will be 5 as well. So statement 2, Jess is more likely to take out a number greater than 6 than a number less than 6. That is incorrect because she actually has an even chance. Because there's the same number of numbers less than 6 compared to more than 6, there is an even chance of picking either one, okay? And for final statement, number 3, Jess is equally likely to take out the number 2 or the number 9. So how many number 2s are there? So if I look at this, how many number 2s are there? There is only one number 2. And how many number 9s are there? There is one number 9. So because there's only one of each, the chance of picking either one is exactly the same, right? You have a fair chance of picking any of these 11 numbers. So there is an equal chance of either picking a 2 or a 9 or a 4 or a 10 or a 6, any of them. You don't have a greater chance of picking a counter just because it has a different number on it. There's an equal chance of picking any of them. So for question 3, statement 3, that is correct. Jess has an equal number. She's equally likely to pick out the number 2 or the number 9 counter. So for question 33, the correct answer, circled the wrong one. Once again, very late at night that I'm recording this one. 33, that one is B. So yes, so that correct, that is B. That is the correct answer for question 33. Okay, moving on. Bruce has a regular pentagon. He makes one straight line cut to divide the pentagon into the 2 shapes. Which of these can he make with one cut? So let's go through them and try to cut them all up for you. Letter X, a triangle and a hexagon. Yes, we can do that. If I cut it like this, the triangle is 1, 2, and 3. These ones, right? And then the pentagon, the hexagon is 1, 2, 3, 4, 5, 6. That has 6 sides. Just remember, it does not have to be. It does not have to be equal sides. It doesn't have to be a regular pentagon or a regular triangle. It can be irregular. So as long as it has 6 sides, or as long as it has 3 sides for the triangle, that counts. So for X, I guess requirement number X or figures X, the figures in X that can be achieved. Let's erase that and try again for the I keep saying number, sorry. Option or requirement Y, 2 quadrilaterals, so 2 4-sided shapes. Yes, you can achieve that if you just cut it down the middle there. So this has 1, 2, 3, 4 sides. And then the one on the left has 1, 2, or maybe I should do it in a different color. 1, 2, 3, 4 sides. So correct. I can get requirement number Y, or requirement letter Y, sorry. I keep saying number. Okay, and then the final one, which is Z, a quadrilateral and a pentagon. Let's erase the top there again, and let's have a look at a quad. Can we get a quadrilateral, so a 4-sided shape, a quadrilateral, 4-sided shape, and a pentagon, which is a 5-sided shape? Yes, we can actually get that. If I cut it like this, I'll get a 4-sided shape here, 1, 2, 3, 4, and I can get a 5-sided shape, 1, 2, 3, 4, 5. So I can also get statement Z. So actually for question 34, I can get all 3. So the correct answer would be E, X, Y, and Z. So that is the correct answer, E, for question 34. Okay, lucky last, final one, and then I'm off to sleep. My old ruler has had some of the markings rubbed off. It only has marks at 0, 2, 3, and 7 centimeters. However, I can still make a line which is 1 centimeter long by drawing between the marks at 2 and 3. So how I can make a line that is 1 centimeter? Yep, cool. So it's just saying that if I look at the space between 2 and 3, that's just 1 centimeter long. So and then similarly, if I look at the space between 3 and 7, that would be 4 centimeters. And then if I look between 0 and 2, that would be 2 centimeters. What length of the straight line can I not make accurately by drawing between the two marks? So it's just looking at which combination of the markings can I use to get the desired length. So for 3 centimeters, let me pick a different color, maybe green. I can actually get 3 centimeters by drawing a line between these two. Okay, so 3 is not the correct answer. Okay, if I look at 4 centimeters, yes, I can get 4 centimeters just by looking between 3 and 7. So that is not the correct answer. 5 centimeters. Okay, so looking at 5 centimeters, yes, I can get that. If I just go between 2 and 7, that is 5 centimeters. So that is not the answer. And then if I look at 6, sorry, D, option D, which is 6. Can I get that? Okay, so I don't think I can get that. Let's come back to that again later. Let's look at option E, 7 centimeters. Yes, I can get that. So if I just go from here to here, that is 7 centimeters. So that is not the answer. That means the correct answer, the one that I cannot make accurately, would be D. So the correct answer for question 35 is D. That brings us to the very end of the OC sample mathematical reasoning test paper. I hope all the explanations were very clear and that you enjoyed going through that with me. My apologies for a few errors where I said the wrong thing late at night after 13 hours of work today. If you do have any questions, please feel free to put it in the comment section below. Otherwise, I hope you found this very helpful, and I'll see you in one of the future videos. Bye-bye.